Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the code problem, minimum number of arrows to burst balloons. I hope everybody has already gone through the problem statement. If you haven't already, do read the problem statement and come back here. So to summarize the problem, we have given some spherical balloons taped onto a flat wall representing XY plane, and the balloons are represented as a 2D integer array points. Point of I equal to x start comma x end denotes a balloon whose horizontal diameter stretches between x start and x end. You don't know the exact y coordinates of the balloons. Arrows can shoot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot x start less than or equal to x less than or equal to x end. There is no limit to the number of arrows that can be shot. A short arrow keeps traveling up infinitely, bursting any balloons in the path. So given the array points, return the minimum number of arrows that must be shot to burst all the balloons. So basically, the problem states that we are given some balloons. Those are arranged in the XY plane. So they can be at any Y, but the X range is given to us. We don't really have to care about the Y-axis. And we have to shot an arrow from X point into the positive Y direction, and it will burst all the balloons which have the diameter the x point from which the arrow is shot is between the diameter of the balloon. Then that balloon will be burst, and the arrow is will be traveling up infinitely, so it will burst all the balloons in the way. And we have to find the minimum number of arrows we can shot to burst all the balloons. So let us understand the examples. In the first example, we are given the points 10, 6, 2, 8, 1, 6, and 7, 12. Let us represent it diagrammatically. So here we can see in the first example, we have 10, 16, and 2, 8, 1, 6, and 7, 12. So we can shot an arrow x equal to 6, bursting the balloons 2, 8, and 1, 6. If we shot an arrow here at 6, we can burst the balloon 2, 8, and 1, 6. If we shot at 11, then we can burst 10, 16, and 7, 12. So we require minimum 2 arrows to burst all the balloons. Now let us see the next case. Next example, we have 1, 2, 3, 4, 5, 6, and 7, 8. If we see the intervals of the balloons or the diameters of the balloons are mutually exclusive. So they are not overlapping. Mutually exclusive means they are not overlapping. So we must require an arrow to burst each balloon. So for 1, 2, we require 1, 3, 4 requires 1 arrow, 5, 6 requires another arrow, and 7, 8 requires 1 arrow. Total, we require 4 arrows to burst all the balloons. In the next case, we are given with the balloons 1, 2, 2, 3, 3, 4, and 4, 5. 1, 2, and 2, 3 are overlapping at 2. So if we launch an arrow at 2, we will burst 1, 2, and 2, 3 in one shot. If we launch, next we have 3, 4, and 4, 5. If we launch an arrow at 4, we will burst 3, 4, and 4, 5 in one shot. So this will take another arrow. So all of the balloons can be burst in 2 arrows. So this, I hope you all have understood the problem. So this problem is almost similar to the merge intervals problem. In merge intervals, we see if 2 intervals are overlapping. If they are overlapping, we merge both intervals. Here as well, if both intervals have some overlapping area, those 2 intervals can be shot by a single arrow. So we can consider everything as a single balloon or something, and we only require one arrow to short the overlapping intervals. But there is a catch, there is a difference between the both problems. In merge intervals problem, if we have, let's say we take this example, we consider the three intervals. If 1, 2 and 2, 3 are overlapping at 2, so we merge these two intervals, and then we consider everything as a single interval, and we go here uh, and we try to merge these two intervals with this interval. Then we see there is a overlapping at 3, so we try to merge this interval with these two intervals, and all the three intervals will become a single interval, and all the three can be considered as a single interval. But in this problem, to short an arrow and burst the balloons, we need a common point between all the intervals. So if we consider these three intervals should have a common x value, so that we can short the arrow at the x and burst all the balloons. If we consider here 1, 2 and 2, 3 has a x value which is common, which is 2. But for 1, 2 and 3, 4, there is no x value in common. So we do not consider them as a overlapping intervals or a single interval. So this problem we can solve similarly as similar to merge intervals, but we have to check that there is a common point. So to check that, we can sort the intervals. We can sort the intervals based on the ending point, and then check if both what are all the intervals that have a common x value to the current interval, and consider them as one arrow. And then we go to the next interval. If we take this case, for example, we have 1, 6. We take the ending point as 6. We see what are all the next intervals which have common point with this current balloon. So we next go to 2, 8. So 2, 8 has common values. So we consider both of them as a single short arrow. And we move next. We check if this, what is this 7, 12. 7, 12 has any common point with 1, 6. How we can check that? We can check the starting value is less than 6 or less than or equal to 6, then it has a common point. But in this case, the starting value is 7, which is greater than 6. So they are not overlapping. We consider this as a new arrow, and then we check then all the next intervals if they are merging with that. In that way, we can count the number of minimum arrows required to burst all the balloons. So I hope you have understood the inclusion. Let us code it up. So in the first step, what we have to do, we have to sort the points in, we have to sort the points based on the ending point. So for that, we can use a comparator, integer dot compare based on the ending value. So we have to give a of 1 and b of 1. After sorting, we have to go through the balloons. We have to iterate over the balloons. And now if it is the starting balloon, we consider it. Or else when we consider as non-overlapping, when the here let us consider the two more values to store result, which is arrows, and we have another variable to store the current ending point. Initially it is 0. If the ending is less than points starting value, then we consider it as non-overlapping. So we start a new arrow here. So we increment the arrows and we update the ending point with this. And finally, we return number of arrows. So what are we doing here? Firstly, we are sorting the intervals, and then this is for counting the number of minimum arrows required, and this is the to keep track of the ending point of the current interval. And we iterate over the balloons, and we always consider the first balloon, so I equal to 0, and ending is less than, we are considering this case. So to start a new arrow, the current ending should be less than the next starting. So current intervals ending should be less than the current points start. Then we increment the arrow and consider, we update the ending point, and then finally we return the arrows. Just run it. It runs all the sample test cases. Let us submit it. It passes all the test cases. I hope you have understood today's problem. If you did understood, make sure you like this video. If you have any doubts, leave them in the comment box below, and make sure you subscribe to the channel for more daily videos. Thanks for watching. Bye.